What is up, guys? In this video I'll be going over the precalc unit 13 quiz for continuity, which is day 6. So yeah. Okay, so our first question is f of x, that's a piecewise function, 2x plus 1, and this is x is greater than 3, and the other function is x minus 1. X is less than or equal to 3, and we were told to find the continuity at x equals 3. So our first step is plugging the continuity value x given into the function where the condition is met. So the first function does not equal 3, so we can't plug it in there, but our second function does include 3, so we plug it in there. So we do 3 minus 1, which is 2. And we now, since we passed step 1, we have to find the continuity, the limit from both sides to see if they're equal. So let's do that. So limit f of x as x approaches 3 from the, call it, let's do from the right side, and limit of x as x approaches 3 from the left side equals, so from the left side it's going to be this first function here, since it's greater than 3. So we plug in 2 here, it's 4, 2 times 2 is 4, plus 1 is 5, and minus 3, approaching from the right side, so it's approaching from the negative side, right? No, it's from the left side, not the right side. So it will be this equation, this function right here, since it's coming from less than or equal to 3, so it's 2. And as you can see, the approaches are not the same, so we write that the limit of f of x as x approaches 3 does not exist, because limit of f of x as x approaches 3 from the left side does not equal limit of f of x as x approaches 3 from the right side. And if we actually graph this function, let me see here. Pull up Desmos. So 2x plus 1, this is greater than 3. Oh shoot. And x minus 1, and x is what? Less than or equal to 3. So as you can see, there's a jump right here, I think. So it's what is it? Non-removable discontinuity, because it jumps, and the limits from both the left and right side are not equal. Okay. Our second question is 2x squared minus 4, and we're told to find the continuity at x equals 2. So our first step is direct substitution, so plug it in. So it's 4, well, let me show the work. So it's 2 times 2 over 2 squared minus 4, it's 4 over 0, so this is undefined. So we immediately conclude that f of x is discontinuous at x equals 2. And if we factor this, we can't factor the numerator, we can factor the denominator, so it's x minus 2, x plus 2, and we can't cancel any factors from the numerator and the denominator, so it's not a whole, it's actually a vertical asymptote. So if it asks for the reason, you just put vertical asymptotes, and we can graph this to show That would be correct. 2x over x squared minus 4. Yeah, there's an asymptote here at x is equal to -2 and x is equal to 2. Yeah. I don't think I put the conclusion for the last one, so I think that's just f of x is discontinuous at what x is equal to 3. A non-removable discontinuity. The type of discontinuity is jump, or not jupe, it's jump or gap. Yeah, I'm not sure if you have to specify what type of discontinuity it is, but just in case. And our last question is 2 over 3x squared, and try to find the continuity at x equals -1. So we plug. Our first step is always direct substitution, so we do 2 over 3 -1 squared, which is 2 over 3 times 1, which is 2 over 3. Next step is finding the limit from both sides, so we do set this to f of x. Limit of f of x as x approaches -1 from the left side equals limit of f of x as x approaches -1 from the right side. And let's plug in like a number like barely smaller than -1, so like -1.1. If you do that, it's still going to approach 2 over 3 because we squared this, so it doesn't matter what type of number we put in here, it's always going to be positive, so it's going to approach the same number. And for this we can put like -0.9. Yeah, and also, yeah, get the point. Yeah, so 2 over 3, 2 over 3. And I think, actually no, we can't do that. Yeah. So we conclude that f of x is continuous at x is equal to -1. Yeah, I don't know the reason. Okay. Alright, thanks for watching.